Hello, welcome, greetings. This is Mr. Burkhart on 2E. We have two blocks are being pushed across the surface with an external force F, as shown in the figure to the right. I guess F is the dude. M1 is greater than M2. Now the mass M2 is greater than M1. The blocks begin at rest. The surface is smooth so that the frictional forces can be neglected. Oh, that's nice. That's ridiculous. The dots below represent the two blocks. Draw a free body diagram showing and labeling the forces, not components, exerted on each block. Draw the relative lengths of all vectors to reflect the relative magnitudes of all the forces. Each force must be represented by All right, well, free space on bingo. Here we have the force of gravity on 2, and here is smaller force of gravity on 1. They each are going to have a normal force against the ground, normal force on 2, the normal force on 1. All right, well, that was the easy peasy part. What's happening over here? Well, this block is being pushed by 1, right? So there's a pushing here, force of 1 on 2. It's being pushed by 1. Block 1 is being pushed by the external force, force external, and it's being pushed by block 2, and this is the force of 2 on 1. These should be the same, pointing in opposite directions. And then this could be, this I guess has to be bigger than that in order for the thing to move. This force would actually have to be shown as being bigger than these two contact forces of the blocks against each other. Derive the magnitude of the acceleration of block 2. Express your answers in terms of boo. Okay, so F equals ma. Yeah, the net external force in the horizontal is F push. So we put here F push equals max. The mass of the system is the sum of the two, so F push equals m1 plus m2 times the acceleration. The acceleration of the system is then ax equals the sum of the masses divided by the force divided by the sum of the masses. Dumb. And since mass 2 will have the same acceleration as the system, the acceleration of mass 2 is the same. Like that. Turning my paper over. Block 3 is now added to the system as shown at right. The three boxes are pushed across the same surface with the same external force F. Indicate whether the magnitude of the acceleration of block 2 is now larger, smaller, or the same as the original situation. All right, so now the same force, but now the mass is 1 plus 2 plus 3. All right, so now the acceleration is equal to F over m1 plus m2 plus m3. I think it's got to be smaller because it's more mass with the same force. That's it. We are done for the week on the worksheets.